Hello and welcome to the second video on wireless mesh networks. This is part of the lecture series Cooperative Communication Systems. So this time we'll speak about fundamental strategies. After last time we discussed what a mesh network is approximately, where it is used and how it works and why it is cooperative. We go into detail this time. So at first, I'll also go a bit more into detail with B.A.T.M.A.N. I introduced this wireless mesh protocol before, and I'll use it as an example to guide to this lecture. Then I'll speak about another type of using a mesh network, which I didn't mention before, which is called flooding, and how is it different from routing. In the third chapter, I'll go very much into detail on how routing works and which methods can be used there. So last time I used exact same steps as you see in this overview and after part 3. But this time we're zooming in and going into detail about each of these steps. So again, B.A.T.M.A.N. B.A.T.M.A.N, which is better approach to mobile ad hoc networking, mobile ad hoc networking, MAN nets being rather dated term for wireless mesh networks, is very much used in the world and part of the Linux kernel since 2011. B.A.T.M.A.N is not a strategy but a protocol, first of all. But I will also show you how the strategies are used with some live demos where I'll log on to a mesh node and show you how it works there. So B.A.T.M.A.N works as a virtual switch in the air. The question is, what does this actually mean? So B.A.T.M.A.N performs all these tasks belonging to the transport layer, the network layer, and the link layer. But it does so within the link layer itself. It means that it hides the execution of those tasks from the other layers, thereby creating something called we could call a virtual switch in the air. This means that any other node would be virtually just one hop away. So the network layer is not routing anymore over B.A.T.M.A.N, as it just exposes a virtual Ethernet interface with a direct connection to any other of the mesh nodes. It's thereby tunneling Ethernet connections through the mesh, even if they're multi-hop. Also, B.A.T.M.A.N preserves the 802.11 medium access control. Maybe you have read about this before, which this is about accessing a medium which is shared, where the nodes use a backoff if they sense the medium is in use at the moment. Also, B.A.T.M.A.N uses the rate selection, which is built in the firmware driver. So now let's talk about those two very different types of conveying a message in a wireless mesh network, which are routing and flooding. In the first video only talked about routing, not to make the situation too complex. Yeah, so let's start where we started, where we ended last time. We have S that wants to send a message to D again, so source and destination. No one is aware of the other nodes, and what flooding would do now is not even necessarily, it can, but it doesn't have to discover its neighbors or do link adaptation, but just flooding the message in the network. This means that the source would be just sending out the message to any of its neighbors, but is broadcasting it there, and they would repeat it for a set number of times. For example, this is done in B.A.T.M.A.N actually, where when B.A.T.M.A.N wants to broadcast the message in the full network, any node would repeat the message 3 times. If it receives the message then again, it would not repeat it. This is very simple, but if you have one link, a bottleneck link in the middle somewhere, it's not guaranteed that the message arrives everywhere. On the other hand, we have routing, as discussed before, which is a lot more complex and a lot more efficient also. So what does this mean now in comparison? So as we've seen, flooding is very simple. Routing looks a little bit more complex, and as a result, we'll have the protocol complexity having being lower in flooding and higher in routing. So it's kind of easy. Also, as flooding is any node that receives a message would contribute there, the efficiency is a lot lower. Airtime efficiency, so we have a shared medium. That means that if a node sends, it can bother other nodes. They can't send at the same time without jamming the other ones, so we need to be efficient in airtime. This is much higher for routing because less nodes are involved. This also means that you can scale routing better normally. Yeah, because it's just you're more efficient, right? Feedback, that's is also a bit limited on how many nodes are transmitting. So doing link local feedback with flooding sounds very excessive. That's why it's in brackets there. While you can certainly flood back with end-to-end feedback. But it's much easier doing this in routing, so this is marked green here.